Good morning to everyone. This is Sri Ramulu. So my channel is SS Physics S.S Physics. So please subscribe it before watching this video for encouragement. Now today's topic is Maxwell's law of distribution of molecular speed. Right. In order to derive the law of distribution of molecular speed, Maxwell made following assumptions. So he made following assumptions. So see here what are those assumptions. The gas consists of molecules with all possible speeds between 0 and infinity. So according to him, there are the five assumptions are there. So before deriving this equation, he assumed the five assumptions are there. So one of them is the first assumption is the gas consists of molecules with all the possible speeds between 0 and infinity. See here, he according to his assumptions, gas molecules having the speed, see their minimum value, the speed of the gas molecule is 0 minimum value and the maximum value is infinity. Okay, next second assumption, the average density of gas enclosed in a vessel in equilibrium is the same at all the places. So he see here, according to him, second assumption is what he is saying, the average density. So average density of the gas enclosed in a vessel in equilibrium is the same at all the places. Suppose if you consider a box, right, if you consider such a box or like this a box, and if you observe the densities, so how much present at this point, the same will present at this point, and at this point is also same present. So that is he is saying. Okay, so the density, suppose if you consider a box like this, rectangular shape, and then how much molecule present here, the same molecule also present at this point and at this point is also, that is the average density of the gas molecule. Average density of the gas molecule is same everywhere, right? Next, though the speed of individual molecules are changing, but a definite number of molecules have the speeds in between the definite ranges. Here what happens, what he is saying, though the speed of the individual molecule, suppose there are the 20 molecules are there in a box, right? So here one molecule and here one molecule and here also one molecules. So this molecule having the certain velocity, certain speed, then this molecule may have the certain speed, though those speeds are within the certain limits only, certain range only. So their range cannot exceed certain values. Okay, and next, the probability that any molecule selected at random has velocity lying between the certain limits is a purely function of velocity and a limit considered. Right, see here what he's saying, the probability that the molecule selected. So take any one of the molecule, probability means your choice. Suppose there are the 20 molecules are given, right, in a vessel, 20 molecules, you may select any one of them. That is a choice comes under probability. So choice is simply probability only. Okay, select any one of the molecules has velocity lying between certain limits. So if you select any molecules, they may have certain limits only, and their velocity is always they are see, and what he's saying, the probability is also what it is, a function of velocity, right? The choosing is also a function of velocity, probability is also a function of velocity. Next, the component of velocity of molecule in three mutually perpendicular directions are considered to be independent of each other. What is seeing, component of velocity? So velocity along the x-axis, velocity along the y-axis, velocity along the z-axis, these cannot depend on one another. Okay, so the velocity in this direction is independent on velocity in this direction, and velocity is also in this direction. So their velocity cannot depends on each other, they are independent, right? Next, So like this, he made five assumptions. And next, let me start. Let us now represent the molecules in a velocity diagram with O as origin and Vx, Vy and Vz as the coordinate axis as shown in figure. See here, it is z-axis and this is x-axis. It is y-axis and this is a point origin. Let us take a molecule. So let me take one molecule having the velocity c, right? Represented by a vector OP. So consider one particle is one molecule is here, and whose velocity is what? Its velocity is c. So from where to where? Here to here. So here the position at a certain position at a point P, one molecule is there. So from here to here, so its velocity component is c. Let the projection of this vector in xyz direction uv and w respectively. So for this particle, for this particle molecule, what its velocity along x-axis is u, along y-axis v, along z-axis is w. Next, all the molecules whose velocity component lie in the range u and u plus du, v and v plus dv, w and w plus dw will be considered will be contained in the element of volume du, dv, dw and dw as shown in figure. What is saying? All the molecule whose velocity component. So molecule, suppose one molecule is at a certain time, let it has a velocity 20 centimeter 20 kilometer per hour, and after certain time its velocity what happens, may change, may increase as 21 or 22, what 22 meter per second, its velocity may change. So that means that there is a small difference. That small difference can be denoted by du. So that is a small velocity along x direction. dv indicates small velocity along y direction. dw indicates small velocity along what, that is along z direction. So like this, that is the initial value, it is the initial value and it is a final value. So along x-axis, and it is initial value and its final value along y direction. It is initial and final along z directions. Okay friends. And next, right, in order to in other words, a point within this element correlated the particle whose velocity component line. Yes, so just now I explained here. So these two things are the same, but right. Next, see here, the probability that a given molecule have its velocity lying between range u and u plus du is a purely function of range u and du. So above just now I explained you the probability is always, it is a function of their velocities only. So probability is a function of velocity, so that is why we write it is a f of u du. Okay, so it indicates a probability of a molecule in terms of its velocity only. So it is taken along x-axis, so that is it may be written as a f of u du. So where f of u is a function of velocity in terms of u. Okay, similarly we write for other things. Similarly, probability that a molecule will have velocity between v and v plus dv is f of e dv. Okay, so how here we have written for this in the same manner. So for v plus dv is if v and v plus dv, for this is also we write f of e dv, and for w also, and for w and w plus w is a function of f of w dw. Okay, right friends, once again, in other words, so right, the probability that a given molecule have its velocity lying between range u and u plus du is a purely function of range u and du. So just now I explained you probability is what, it is a probability means it's chance is a probability is what, always in terms of velocity range is the velocity only. So that is why the probability along x direction, so probability along x direction what he's taking, so he's writing as a f of u du, where f of u is a function of velocity u. Okay, so here the molecule is traveling along x direction. Okay, then its probability function can be written as f of u du. Why? Because probability function is always it is a function, probability is always is a function of velocity, so that is velocity is along x direction. Similarly, we write here, similarly, probability that a molecule will have velocity between v and v plus dv is f of v dv, and between u w and w plus dw is f of w dw. So how we have written for u here, here in the same manner, for v also we write f of v dv, for w also. So probability of molecule along z direction is f of w dw. Okay friends, and next we know that probability of a composite event is equal to the product of probabilities of individual events. Okay, so what he's saying, we know that the probability of composite events means probability of all the molecules in a system is always equal to probabilities of individual events. So probability of individual particles. Okay, so probability of whole thing is always equal to probability of individual things. So probability of whole thing is always what it is equal to probability of individual molecules or individual things. So like this we can write it. So but it is always product, in terms of products only. Okay, so what he is saying once again, the probability of composite event is equal to the product means multiplication, product of the probabilities of composite individual events. Okay, right. Next, hence the probability that a molecule will may have velocity components lying between u plus du, v plus dv, w and w plus dw is given as. So for it is for individual, it is not whole things. So product of individual. So here product is taken. See, this is already given above, where it is this product into this into this. So product is taken, right? So their product, and here that's what I have written just to f one side, and this one side I have written that's it only, but they are in product. So it is a probabilities of individual, right? So product of probabilities of individual events, and a composite event is we take like this. Okay, right. Then the resultant velocity of the molecule in a single vector c, the probability that this velocity of value c lies in the element of volume du dv dw is a function of c, and du dw. Okay. Here what is saying, the resultant means a product, this whole composite and individual, their value he is saying. So the composite, how can we write composite is a always it is a it's a composite velocity is a c, composite it c is a composite velocity, and uv are the individual velocities of the molecules in x y z direction. It is a composite that it is in space only, composite. Okay, and let's see, if you multiply du dw, it indicates what, its meaning is volume of considered area. So consider the space, not area, consider space, volume is du dv dw. This may be expressed as, so composite may be expressed as, so this means composite function. Okay, so small functions is individual functions dw, or for more convenient, so for more convenient, instead of taking f of c, we can take phi of c square, we take du dw, where phi is denotes some function, so we can write, so phi is also one function, so it is a composite function. So product of individual event is always equal to probability of composite function. So it is a probability of individual, it is a probability of composite. Okay, next, and see on either side what you have, same thing you have, so they gets cancelled, the remaining thing is this one. And where c is what, c square can be written as like this. So how we have taken here, c square as this one. So already, so please let me keep this topic side just for few minutes, so to know how we got this one. So in parallelogram, in parallelogram, so vector in intermediate, right? So in intermediate you have taken this side as a p vector, and this side as a q vector you have taken, and the resultant vector is in this direction, that is denoted by what, r. And how you write resultant vector r as what? So it is r is equals to under root what, p square plus q square. You have, you know that this is how to write. Okay, and if you remove this under root, then what you get? You may get r square is equals to what, is equals to p square plus q square, you may get. Okay, for two vectors what we have taken, for two vectors only, see, it is one vector in vector, so the resultant vector is r square. So here what, here is also u v w are the vectors, vector components along xyz axis, and c is a resultant vector, so already given in the above, it is a vector quantity. Okay, so this is we write. And for, instead of taking a p q, if you take here u and v, so it is for two dimension. For three dimension what you have take, you have take w also. So, and instead of a resultant taking r, take c. So c square is equals to u square plus u square plus v square plus w square, you may get. So like this, we got this one. Okay friends, let me go next, and let it is equation number one, so don't forget this one. All right, to solve the equation one, so above equation is what, it is equation one. To solve this equation, here certain assumptions are required. So what are those assumptions? Let me explain. To solve the equation one, we note that for a particular value of c chosen as a pi of c square is a constant. To solve this equation, what he's saying, take this is as a constant, he's saying. So hence we know differentiation of constant is always what, it is 0. Okay, if you differentiate the constant terms, you get 0. Am I right? Next, now for this what I am doing, for this for this to this equation, either this equation or this equation, for this equation what I am doing, I am differentiating on both sides, so this side and this side. Okay, so that is why here d is written and here also d is written. Okay, so then now see, uh, right one. Okay, now, so differentiating on both sides, so differentiation what it gives, so it gives constant term, that is why its value is 0. Okay, but here differentiation, for this differentiation is what you have, see here three different quantities are there, so it is a UVW differentiation. So you know UV differentiation, you know, so that is what UV differentiation, U dash V plus V dash U, you know. Okay, for three UVW, what you have to do, for three things, what you have to do, you have to do first to differentiate first quantity and keep remaining two quantities same. So for this differentiation, put here dash, and it is a function of u, and right here this u, so that means it is a du, only for u is differentiated, its meaning. And next plus, and next time keep u and w as it is, and differentiate to the v. So for differentiation of v, right here dv. Okay, next plus, and now keep u and v constant as it is without doing differentiation, and do the w. So then you get here f dash, and we are doing for w, so that is why right here dw. Okay, so it indicates what, it indicates only w function is differentiated here, v function is differentiated here, u function is differentiated, that is its meaning. Next, where f of u, f dash of e, f dash of e, and f dash of w represent their respective derivatives, so they differentiate, it indicates. Next, dividing equation 2 by f of u, f of e, f of w, what here we have to differentiate, which equation here we have to see here what is there, so we have to differentiate to equation 2 with what, with this one. Okay, so that means write this value whole divided by this. Okay, then so this by this, then we can separate it, this by this, and this by this, and this by this also we write. Then what happens if we write this by this, so here these two and these two gets cancelled. Why? Because why these two gets cancelled? Why? Because here f dash of u is there. Okay, friends. Now see what we have to do. So dividing this by what? This value. Okay, then we can separate actually whole divided by this one. Then we write this by this value, this by this value, and this by this value also. Now write it this by this. Then what happens? These two gets cancelled. Why? Because here you have f only, but it is f dash. F and f dash cannot be cancelled. That is the reason. Okay, so what remains here? F dash u by f of u into one more thing is there, du. So that is why I see here it is. Okay, next this by this. Okay, this by this means f of u, f of u, f of w, f of w gets cancelled, and here f of e remains and f dash of e remains, and dv is also remains. So f dash of v by f of e. So here f dash of v by f of e remains same, no change. And next for this also, this by this we have to write. Okay, then these two gets cancelled and these two gets cancelled, but here f dash of w is there and it is f of w, so these two cannot get cancelled. So that is why, and into dw is also there. Then this by this, so that is we get this one, and it equals to what? 0. So that is why 0 is taken. Next, so let it is equation number 3. But we know that what? U square plus v square and w square is what? C square. Yes, already we have here in equation 1. Okay, next here. Now to this equation, just differentiate it. How we differentiate it? How do we have to differentiate? So it is for u square, just to care, just for if it is x square, how do you differentiate? 2x into dx by dy we write, 2x into dx we write like this only. So here you for v is u square, 2u into du it indicates it is differentiated, not with respect to any other. Okay, next for this v square also, just write 2v dv. So v for v square 2v dv, for w square 2w dw. Okay, here a 2 and a 2, and here also 2 we have, and these two take out of the common and bring this side, it becomes 0. Let it equation number 4. Next, multiplying equation 4 with lambda we get. So for this equation, just to multiply with lambda. So here lambda we get, here also lambda we get, here also lambda we get. So it is equation number 5. Now add equation 3 and 5. So add these two equations. Okay, how do you have to add? So this value plus this value, so we get this one. Next, this value plus, not this value, not this, is this value. Okay. Okay, we get this one. So this value plus this value, what we get? We get this one. Am I right? So these two value gives this one. Okay, so now take here du common, so then we write like this, and dv common, this one we get, dw common, we get this one, and let it is equation number 6. Since uv and w are independent of each other, in equation 6 equation 6 can be satisfied only if each of the term is separately equal to 0. See here what he's saying. So their sum is always what? It is 0. So that means either this one 0, this one, if keep here 0, here 0, here 0, and here 0, then what happens? 0 plus 0, 0 only. So this equation is satisfying. That means this must be 0, and this must be 0, and this also must be 0. So their individual values are zeros like this. Let it is equation number 7. Now consider the first equation of the 7. So in the 7, first let me take first equation. Okay, taken, and if it come outside, it becomes 0, and it is a positive term, it will bring this side, it become negative. So we can write like this. So this equation can be written in this manner. Am I right? Okay. Okay. So now, so to this equation, just integrate it on either side. So integration, what is it is, it is one function, and then it is a differentiation of this function. Okay. So this function is a differentiation of this function. So integration, what we write, so when it present like this, so when integration of function, if it is a function one and it is a, it's a derivative, okay, then what happens, we write log of f of log of f, we write. Okay, so that means only this here we are write in the same manner. So this is what it is, a differentiation of this one, so then we are writing log of f of u only. So which one present here, only that is here you have to write. So here f of u is there, so that is why f of u is taken. And next what it is a du is there. So du means what, when it is a du, then lambda is a constant quantity. I'll just know above it is expand multiply with lambda, minus and lambda take outside, and a u integration, see integration u du can be written as u square by 2 plus, while we are integrating we must take a constant. But when you get one, uh, when you get logarithm in integration, next to constant also should be taken in terms of logarithm only. Okay, so the students, those who have knowledge on integration, they can easily understand. Okay, and now see where log of log a base e is a constant of integration, right? What I'm saying, it is a constant of integration. Uh, now bring this side. When you bring this side, what happens, this positive become negative, right? So now we have one formula, log a minus log b formula we get here. Okay, so what is the formula for log a minus log b? Log a minus log b formula is log of a by b. Okay, log of a by b. So that is why it is a value, and this is a, if we bring this side it becomes minus. Okay, this one become minus, then what happens, then usually it is a b value, it is a value, so then we write log of f of, is log of f of u by a. Okay, so please note down this formula is used here. Okay, log a minus log b, log a by b. When you bring this side, then it becomes minus, positive becomes negative. If it comes this side, then this formula is applicable now. And this is as it is written here. Okay, next, now write in anti-log. What is anti-log formula? Log x base e is equals to a. Suppose the formula is like this, then how we write, e power a is equals to x. So bring this is and keep it on head of the e and write equal to e, this one. Okay, so now apply this formula here also. So to this e write this whole term on its head and make it equal to e, this one. Same thing you see here. So x, it is x, it is a, it is a is written on head of the e and it is equated. Okay, same thing, so write this, take this value and keep it on head of the e. So here on head of the e is kept and make it is equal to this one, so it is written. Now bring a value this side, so then what you get, you get this one. So it is f of u e into e power of minus lambda u square by 2. And once again lambda by 2 can be taken as one more constant, so only lambda by 2, not minus, only lambda by 2. So that is why f of u is equals to a into e power of minus b u square. So okay friends, so let it is equation number how many, it is eighth one. Now similarly, so for what here I have taken only the first function. I didn't take remaining two functions, but when we got the value this one by using the first function, the similarly we can write to the remaining two functions also, same thing. Okay, by just replacing in the place of u, we can solve it one, and in the place of u, if you replace with w, then you can get the in terms of w functions only. Okay, that is also okay. So for similarly have taken here, similarly for other two components we can write. So how we have written for the first component, for the second component also we same thing we have to take in the place of u, V and W is taken, and A is same everywhere same, and B is also same. But here U square, V square, W square. Why? Because it is in terms of function, in terms of W, it is in terms of V, it is in terms of U. And let it is equation 9 and 10. It is 8th one. Okay, 8, 9, 10 equations are there. And as from equation 8, 9, 10, what I have done, I am multiplying equation 8, 9, 10, multiplying. When you multiply, then we get like this only. Okay, so these functions are multiplied this side, and this function also multiplied this side. Okay, a become a cube, and if you we know here minus bu square minus bv square minus bw square, so take outside minus b, so then you write like this only. Now the constant a and b, here this constant and a b can be found by integrating above equation, applying the boundary conditions. So if you have to calculate the b value and a value, what we have to do, we have to integrate to the above equation. Here three quantities are there, so that is why I have multiplied three times. I am integrating three times. And before that, what is here? Let n be the number of molecules per cc. What is the meaning of n? N is the number of molecules. Per cc means what? Cubic centimeter. In 1 cubic centimeter, how many number of molecules are there? That is denoted by small n. Okay, friends. Small n is what? Number of molecules per cc means cubic centimeter. Okay, of the gas with all the possible velocities from minus infinity to plus infinity. So here what I'm taking, I'm integrating this above equation to get a value and b value. I'm taking limits minus infinity to plus infinity. Okay, so it is on formula. Please remember, please keep in mind, n into triple integral minus to plus infinity f of u, f of v, f of w, du, dv, dw is equals to n. And I cancel it this one, then what you get here? You get one only. Okay, and now so finally it is the same thing. And next f of u, we know this function, this value. So what is its value? Its value is this one. Take and substitute here, then you can get this one. Okay, it is as it is copy pasted. Okay, friends. Okay, now so this equation, we we know that value of definite integral. Here how many integrations are there? Three integrations. So one for u and another for v, and last one for w. Okay, I'm taking a single I'm taking. So for it is integration for minus infinity to plus infinity for all. Okay, individual I have taken individual minus infinity to plus infinity e power of minus b u square. So only for, I have taken this one. Next time I will take b into v square I will take. Okay, for taking this one, what happens, when we take like this, then it is very difficult to solve. So but it has a direct formula, so please remember this one. So when you have like this such a equation in this manner, so when you have like this equation, then what you have to, so minus infinity plus infinity, then whatever value coefficient is there for the this term, square term, and write it is in denominator pi by under root pi by a. Okay, but for all the three things, what you get, we get the same value, same thing. So that is why because it is a b coefficient is the same to all, so that is why here the same formula we get. Okay, same formula we get. Okay, so same formula. So and take these three integrations and substitute in this equation here, then what we get here? See, we get a cube into this for see, in the place of minus b square, it is under root pi by b is written. In the place of e power of minus bv square, then in the place of that it is written. In the place of minus bw square, so it is written. A cube is as it is, and if you multiply them, then what you get? You get it is pi by 3 power 3 by 2, pi by b power 3 by 2. Okay, friends, pi by b power 3 by 2. Okay, so pi by b power 3 by 2, and bring this whole terms this side, then these two gets reversed when you bring this side, and these two also reversed. Okay, so when you bring this side, all the quantities becomes reversed. So a denominator term goes numerator term goes denominator, and a denominator term comes in numerator, and same thing here, 3 by 2 becomes 2 by 3. So it is it is a value. Okay, and now here b is a constant, has actual formula. So b is a constant, but it has actual formula. But what we have taken in the above equation, b is replaced by lambda by 2 only. Okay, b is written in the place of lambda by 2, but it has actual value, that is what, m by 2 kt. Okay, b value is what, m by 2 kt. So substituting this value in the above equation we have, so substitute here this term, then you get this one only. Okay friends, now so it is, we got like this, it is a b value, b constant and a constant. So above what, where we have written here, constant a and b can be found by integrating. So we found those two things, a value we found like this and b also we found like this. Okay, thus the number dn molecule having the velocity components lying between u and u plus du, v and v plus dv, w and w plus dw is given by. Okay, so it is a, it is one more formula. So not it is integration and differentiation is formula. N means we know number of molecules per cc, cubic centimeter. Dn is also number of molecule per cc, but a small value it is. It is very small value, and it has a formula like this. Dn is equals to n f of u d, f of u, f of e, f of w, du, dv, dw. It is a formula for dn for the small value. And already we got these two values, three values, and that is what, it is a value of this one. Okay, for what, for this one only, into n as it is copy pasted, into it is also pasted. Okay, so see here where we have taken in the place of this is, it is written. Okay friends, now substituting a and b value. So just now above we have calculated a value and a b value, takes a value here and a b value here. Okay, then it is final formula. Okay, or we can write like this also. Okay, so this formula we use in the last unit, that is in statistical mechanics. Not only this formula also we use. So friends, please keep in mind, it is a very very important formula. So n into m by 2 pi kt power 2 by 3 e power minus m by 2 kt u square v square plus w square du dv dw. And it is in terms of this, in terms of c, it is a dn is equals to 4 pi n m by 2 pi kt power 2 by 3 power minus mc square. So means in the place of this is c square is written only, that's it. Okay, right friends, so this is what Maxwell distribution law. Okay friends, so it is a very very important thing. So once again, please see from top. So it is, if you want to take it is a screenshot also, and prepare a notes, right? Okay friends, don't feel it is a lengthy, but it is very important. Okay, thank you.